High in the Cascade Range of southern Oregon, the Earth opens into a caldera so vast and so impossibly blue that seeing it feels less like discovery and more like intrusion. The rim sits nearly 8,000 feet above sea level, encircling water that drops 2,000 feet into darkness. No river feeds it. Rain and snow alone fill this basin, yet it holds 5 trillion gallons of water so pure you can see objects 100 feet down. The blue is not a reflection of the sky. It comes from within the water itself. The Klamath people say the lake is sacred, a threshold between worlds. Geologists say beneath it lies a collapsed mountain. And when researchers sent submarines to the bottom, they found something nobody expected. If you are new here, this channel covers the ancient mysteries buried beneath American soil that most people were never taught. Subscribe and let us know if you had ever heard the real story of Crater Lake. What the geological record actually shows is a story of unimaginable violence. Roughly 7,700 years ago, a stratovolcano known today as Mount Mazama dominated the southern Oregon skyline. It stood, according to geological reconstructions published by the United States Geological Survey, at approximately 12,000 feet, making it one of the most prominent peaks in the entire Cascade chain. Mount Mazama was not dormant, it was not quiet. It was a system under extraordinary pressure, fed by magma chambers that had been building energy for millennia. When it finally erupted in what volcanologists classify as a catastrophic caldera-forming event, the explosion ejected an estimated 12 cubic miles of magma and ash into the atmosphere. To put that figure in perspective, the 1980 eruption of Mount St. Helens, which devastated hundreds of square miles and killed 57 people, ejected roughly 1 cubic mile of material. The Mazama eruption was, by conservative estimates, roughly 40 times more powerful. The ashfall from this single event has been identified in geological deposits across 8 modern states and 3 Canadian provinces. Charles Bacon of the United States Geological Survey documented pyroclastic flows that traveled at hundreds of miles per hour, incinerating everything in their path across distances of up to 40 miles from the summit. The mountain did not merely erupt, it emptied itself. The magma chamber beneath the peak drained so rapidly and so completely that the entire upper structure of the volcano collapsed inward, creating a caldera roughly 5 miles wide and nearly 4,000 feet deep. Over the centuries that followed, rain and snowmelt slowly filled this depression, producing what is today the deepest lake in the United States and one of the deepest in the entire world, measured at 1,943 feet at its greatest depth during sonar surveys conducted by the National Park Service. But what makes Crater Lake extraordinary is not merely its depth or its origin. It is what persists there, in the water, on the surface, and in the stories that predate European contact by thousands of years. The Klamath people, whose ancestral territory encompasses the lake and the surrounding highlands, possess an oral tradition that describes the formation of Crater Lake with a specificity that has astonished geologists and anthropologists alike. According to Klamath oral history, as recorded by the ethnographer Ella Elizabeth Clark in her 1953 work Indian Legends of the Pacific Northwest, and corroborated by earlier accounts from Army officer Captain O.C. Applegate in the 1870s, the lake was created during a catastrophic battle between 2 powerful spirit beings. Lauau, the spirit of the underworld, resided within the mountain. Skel, the spirit of the sky, inhabited Mount Shasta to the south. The 2 beings waged a terrible war, hurling fire, rock, and darkness at one another across the landscape. The earth shook. The sky turned black. Mountains crumbled, and when the battle reached its climax, Lau's mountain collapsed upon itself, trapping the underworld spirit beneath a lake of water that sealed the passage between worlds. This is not a vague creation myth, loosely mapped onto a geological feature. This is a precise narrative sequence. Volcanic eruptions described as thrown fire and rock, the darkening of skies consistent with massive ash clouds, seismic activity, and the ultimate collapse of a mountain summit that matches the geological evidence with remarkable fidelity. Dr. Bacon himself acknowledged the correlation in published work, noting that the Klamath oral tradition constitutes one of the oldest verified oral accounts of a geological event anywhere in the world, preserved with accuracy across nearly 8 millennia of continuous transmission. The Klamath did not treat the lake casually. For generations, they considered it a place of enormous spiritual significance, a location where vision quests were undertaken, and where the boundary between the physical and spiritual worlds was understood to be dangerously thin. When European Americans arrived and began treating the site as a scenic curiosity, the Klamath reportedly warned them that the lake demanded respect, that it was not merely water in a hole, but a living threshold. What the historical record actually shows about European contact with Crater Lake begins on June 12, 1853, when a group of prospectors, searching for a rumored gold mine, stumbled upon the caldera rim. John Wesley Hillman, a young miner from the Willamette Valley, is generally credited as the first European American to see the lake, though the party included at least a dozen men, and the question of who first laid eyes on it remains a minor historical dispute. Hillman and his companions named it Deep Blue Lake, a name that would change several times over the following decades, to Lake Majesty, then to Crater Lake, before the current designation became official. Hillman later recalled being so stunned by the sight that he nearly rode his mule over the edge of the rim, the caldera wall dropping away so abruptly that neither rider nor animal realized they were approaching a cliff. Interest in the lake grew slowly at first, but accelerated dramatically after William Gladstone Steele, a Kansas-born conservationist who had read about the lake as a teenager and became obsessed with its protection, began a 17-year campaign to secure federal preservation for the site. Steele first visited Crater Lake in 1885 and was so profoundly affected by the experience that he dedicated much of the rest of his life to ensuring it would never be commercially exploited. His efforts culminated on May 22, 1902, when President Theodore Roosevelt signed the act establishing Crater Lake National Park, making it the 5th national park in the United States, and the only one created specifically to protect a body of water. But Steele's legacy at Crater Lake extends beyond political advocacy. In 1886, he organized one of the first scientific surveys of the lake, dragging a small boat up the caldera wall and lowering it to the water's surface, a feat that required tremendous physical effort given the steep, unstable terrain. During this expedition, depth soundings were taken using piano wire weighted with lead, producing the first measurements of the lake's extraordinary depth. Steele also noted something peculiar during his visit that would become one of Crater Lake's most enduring mysteries. Floating upright in the water, bobbing gently with the currents, was a mountain hemlock log approximately 30 feet long and roughly 2 feet in diameter. The log was not lying flat on the surface as driftwood normally does. It was vertical, with roughly 4 feet protruding above the waterline and the rest submerged beneath, moving freely across the lake's surface, as though guided by some invisible current. This object, which came to be known as the Old Man of the Lake, has been continuously observed and documented for well over a century. It was already weathered and bleached when Steele first noted it in the 1880s. Naturalist Joseph Diller studied it in the early 1900s. Park rangers have tracked its movements since the 1930s, and radiocarbon dating conducted in later decades suggests the log has been floating in the lake for at least 450 years. The old man moves, not randomly, not predictably, but with a kind of slow deliberation that has unsettled observers for generations. During a 1938 study, park naturalist John Doerr tracked the log's position daily and recorded it traveling over 60 miles across the lake's surface in a period of just a few months. It drifts against the wind, pauses, reverses course, and navigates around obstacles. Scientists attribute this movement to thermal currents within the lake, subsurface winds, and the unique hydrodynamic properties of a waterlogged vertical object. But the explanation, while plausible, does not fully account for the log's longevity. Hemlock wood submerged in water should decompose. It should become saturated and sink. It should not remain buoyant, upright, and structurally intact for centuries. The cold temperatures of Crater Lake, the surface averages around 55 degrees Fahrenheit in summer, and the deep water remains a constant 38 degrees, are believed to dramatically slow decomposition, effectively preserving the wood in a state of suspended decay. But even this explanation raises questions. The Old Man is not the only piece of wood that has entered Crater Lake over the centuries. It is the only one behaving this way. Subscribe now because what researchers found at the bottom of this lake is something nobody expected. What researchers actually found when they finally explored the bottom changed the scientific understanding of Crater Lake entirely. In 1988 and 1989, a team led by Dr. Jack Diamond of Oregon State University, in collaboration with the National Park Service, deployed a one-person submarine called Deep Rover to conduct the first comprehensive survey of the lake floor. The submersible descended through water so clear that visibility exceeded 100 feet even at extreme depths, passing through thermal layers that shifted from cold to unexpectedly warm and back again. What they found at the bottom was not the barren, featureless volcanic basin that most scientists had predicted. The lake floor was dotted with hydrothermal vents. Warm, mineral-rich water was seeping up through the fractured volcanic rock at the bottom of the caldera, creating localized temperature anomalies that had never been documented in a freshwater lake at this elevation. Some of these vents were producing water temperatures significantly above the ambient 38 degrees of the surrounding deep water, with measurements near certain features reaching as high as 68 degrees Fahrenheit. Bacterial mats, thick living carpets of thermophilic microorganisms, surrounded the vents, thriving in conditions that were supposed to be impossible in a lake that receives no external water input and sits at over 6,000 feet of elevation. The discovery was published in multiple peer-reviewed journals, including work by Diamond and colleagues in the journal Nature in 1989, and it fundamentally altered the understanding of Crater Lake's chemistry and biology. The hydrothermal vents explained several long-standing mysteries. Crater Lake's water chemistry had always been slightly anomalous, with elevated levels of certain dissolved minerals, chloride, sulfate, sodium, that could not be accounted for by rainwater and snowmelt alone. The vents provided the missing input, a deep geological source feeding minerals directly into the lake from the still cooling magma system beneath the caldera. This also meant that Mount Mazama, despite its catastrophic collapse 7,700 years ago, was not geologically dead. The magma system, that had powered one of the most violent eruptions in North American history, was still active, still producing heat, still circulating fluid through fractured rock and into the lake above. The United States Geological Survey continues to monitor the site, and while no imminent eruption is predicted, the system is classified as a potentially active volcanic center. The submarine explorations also provided detailed mapping of the lake's two most prominent geological features. Wizard Island, the volcanic cinder cone that rises roughly 760 feet above the lake surface near the western shore, was confirmed to be a post-caldera eruption feature, formed by volcanic activity that occurred after the initial collapse of Mount Mazama. The island's crater, which sits at its summit and is itself about 300 feet in diameter and roughly 90 feet deep, is a volcanic vent that produced lava flows now submerged beneath the lake's surface. Miriam Cone, a second volcanic feature entirely submerged beneath the water, rises approximately 1,480 feet from the lake floor, but remains roughly 100 feet below the surface, making it invisible from the rim, yet nearly as tall as Wizard Island measured from base to peak. Then there is Phantom Ship, the jagged rock formation near the southern shore that resembles a ghostly sailing vessel when viewed in certain light conditions, particularly at dusk or when fog rolls across the surface. Phantom Ship is not a post-caldera feature. It is composed of some of the oldest exposed rock in the entire caldera, andesitic dikes estimated to be roughly 400,000 years old, remnants of the original Mount Mazama volcanic system that survived the collapse. The formation stands roughly 160 feet above the waterline, and its resemblance to a ship is so striking that early visitors to the lake routinely reported seeing a vessel on the water, before realizing the object was stone. What the evidence suggests about the water itself may be the most remarkable aspect of Crater Lake. The blue color, which has been described by visitors and scientists alike as unlike any other body of water on Earth, is not caused by algae, minerals, or reflected sky. It is a product of the water's extraordinary purity and depth. Because Crater Lake receives water only from direct precipitation, with no inflowing streams carrying sediment, organic material, or dissolved particles, the water contains almost no suspended matter. When sunlight enters this exceptionally pure water, the longer wavelengths, reds, oranges, yellows, are absorbed by the water molecules themselves, while the shorter blue wavelengths are scattered and reflected back to the observer's eye. The deeper the water and the fewer the impurities, the more intense this selective scattering becomes. Secchi disk measurements, the standard scientific test for water clarity, have recorded visibility depths at Crater Lake exceeding 140 feet, placing it among the clearest bodies of water ever measured anywhere in the world. A limnological study published by Oregon State University researchers in 2002 confirmed that the lake's clarity had remained remarkably stable over decades of monitoring, attributed to its isolation from external pollution and the ongoing cycling effect of the hydrothermal inputs. But the clarity has not been entirely constant. In the 1980s and 1990s, park scientists noticed a slight but measurable decline in water clarity, a trend that prompted concern about possible human impacts even in this seemingly pristine environment. Research by Dr. Gary Larson and others at Oregon State University identified several contributing factors, including the introduction of non-native fish species, kokanee salmon and rainbow trout, stocked for recreational fishing beginning in the early 20th century, which had altered the lake's nutrient cycling by introducing organic waste into a system that had evolved with almost no biological input. The National Park Service ceased fish stocking in 1941, but the introduced populations persisted, and their ecological impact became a subject of ongoing study and debate. Temperature anomalies within the lake have also drawn sustained scientific attention. While the surface water follows predictable seasonal warming and cooling cycles, deeper measurements have revealed unexpected thermal stratification patterns. During the submarine surveys of the late 80s, researchers documented zones where water temperature deviated significantly from the expected thermal profile, creating pockets of warm water at depths where near-freezing temperatures should have prevailed. These anomalies were concentrated near the hydrothermal vent fields, but were also detected in areas where no obvious geological heat source was present, suggesting either undiscovered vent activity or complex convective circulation patterns that remain only partially understood. A long-term monitoring program has been tracking these thermal patterns for decades, and while the hydrothermal explanation accounts for much of the observed variation, some measurements continue to defy straightforward interpretation. The relationship between the Klamath people and Crater Lake also warrants deeper examination than most popular accounts provide. The oral tradition of Lau and Skell is the most widely known element of the Klamath connection to the site, but the cultural relationship extends far beyond a single narrative. The lake occupied a central position in Klamath spiritual practice, serving as a site for vision quests, prayer, and communion with spiritual forces that the Klamath understood to inhabit the caldera. Young men seeking spiritual guidance would climb down the caldera walls, a dangerous descent that drops nearly 2,000 feet over unstable volcanic rock, to reach the water's edge, where they would fast, pray, and wait for visions. The practice was not undertaken lightly. It required preparation, resolve, and an acceptance of genuine physical danger, all of which underscored the profound importance the Klamath placed on the lake as a spiritual threshold. When the area was designated a national park, the Klamath lost formal access to a site they had stewarded and revered for nearly 8,000 years. This displacement is part of a broader pattern in American history, one in which the creation of protected natural spaces frequently came at the direct expense of the indigenous peoples who had maintained those landscapes for millennia. What modern science continues to reveal about Crater Lake suggests that the story is far from complete. Ongoing research has produced increasingly detailed models of the lake's hydrology, chemistry, and biology, yet significant questions remain open. The precise rate and chemistry of hydrothermal input into the lake continues to be refined. The long-term ecological consequences of the introduced fish species are still being assessed. The full extent of the subsurface volcanic system beneath the caldera has not been mapped, and the old man of the lake continues to drift, upright and unexplained in its longevity, across the surface of water so blue and so clear that looking into it feels, according to more than a few visitors, less like looking at a lake and more like looking into something that is looking back. Perhaps the Klamath were right all along. Not in the literal details of gods throwing fire at one another across the Cascade sky, but in the deeper recognition that this place is different, that the water filling this shattered mountain is not simply water, but a record of catastrophic violence preserved in stone and silence. A record of ecological resilience in a system that rebuilt itself from total destruction. A record of human memory stretching back to a time before writing, before agriculture, before almost everything we consider civilization, yet accurate enough to survive independent scientific verification nearly 8,000 years later. Crater Lake does not offer easy answers. It does not resolve neatly into either the supernatural or the purely rational. It sits, as it has always sat, in the space between what we know and what we have not yet learned to ask. 1,943 feet of blue silence, holding its secrets in water so pure you can see through it, and so deep you will never see the bottom. If this is the first time you have heard the full story of Crater Lake, drop it in the comments and subscribe for more of the ancient and unresolved corners of this country.